This project is really about some of the results that we found from water sampling. We'd hoped to do water sampling in 2020 and 2021, but as you can imagine, there wasn't a lot of water moving in 2021. So really the big focus of this is going to be what we saw in 2020. One of the reasons that we wanted to do this work, first of all, is really because of what I've seen in my background. Before I came up to Minnesota about 3 or 4 years ago, I was in Ohio, and we had a lot of water quality issues that were taking place with the Western Lake Erie Basin, and farmers being blamed for harmful algal blooms. But one of the things that really helped protect farmers in that situation was having data and having some knowledge of what the water quality losses were on farm. And so that was one of my big goals for when I came up here, is trying to get some things established for Northwest Minnesota. The work that Discovery Farms does in the southern part of the state is really important, but as you all know, there's a lot of Minnesota north of I-94, so that is what I'm working on. So. These are just a couple pictures. You can probably dim the lights now and mostly go to the slides. And these are just some pictures I took actually just from around the Research and Outreach Center in 2020. And this was an extremely wet growing season. We had soil moving. Some of our cornfields had standing water in them in July, which is really, really unusual, for really any year. Ponding all across our fields, whether they were sugar beets or corn. So this was a really unusual year from that standpoint, where you had a lot of water moving, a lot of soil moving also. And then contrast that with what was happening in 2021. Fields were so dry. These are just a couple of shots from inside the drainage, some of my drainage research plots that we have at the Northwest Research and Outreach Center. And we have really deep soil cracks. I kind of put one crack next to a water bottle kind of for scale, so you can see just how wide that soil cracking was. We also saw cracks that ran straight through the wheat rows, so it's just kind of a contrast that we had so much water that it couldn't all absorb in 2020 versus in 2021 our clay soils were shrinking and cracking and creating potentially preferential flow pathways. And that really kind of bared out in the rainfall that we saw. This is the annual rainfall for both 2020 and 2021. One thing to note is I actually started the year in September because, as you guys all know, we start banking that water as soon as the previous crop comes off. And so we, in 2020, started to see a lot of rainfall starting as soon as September, and then that continued, so really wet fall, and then a really wet spring. The black dashed line that's on there, that's our 30-year average. So it kind of, what is average? Some years there's a lot, and sometimes there's little, and it kind of comes out in the middle. But you can see 2020, we were so far above average. But then in really big contrast, 20 and 21, so far below average. And what that kind of bears out as we lost a lot of water and surface runoff. We did see the surface runoff, that surface ponding that was in the previous slide. That's really a result of all that rainfall that we had in July. That was falling, not only was it a high amount, it was falling at a rate that was greater than the soil could absorb it, so that's causing runoff events. And so what we did, mostly in 2020, is we collected water samples at our newly drained site at the Research and Outreach Center in Crookston, and then also 4 other on-farm locations. And we took grab samples. They were all tile-drained locations, so we could get a good picture of what was in the tile runoff versus what was coming off in any surface ditches. So that gray structure there, that's an automated water sampler. We're doing continuous water sampling at these drainage plots at the Northwest Research and Outreach Center, but we supplemented that with graph samples from the on-farm locations so we can kind of get a general idea of what's happening at a really fine scale at one location, and then spread that out and look at what's happening and kind of try to correlate maybe some differences between sites across the farms. And then, of course, we did data analysis in the lab. We ran all the water samples. We ran them for nitrates, total nitrogen, dissolved phosphorus, and total phosphorus. And you guys have heard me speak before. You know, since our water goes north into Lake Winnipeg, we are also concerned not only about nitrate losses for drinking water, but also for phosphorus losses, because those come into play if there are any algal blooms in Lake Winnipeg, which will make our Canadian neighbors really mad. So we don't want to lose too much phosphorus, and we don't want to lose much nitrogen from a water quality perspective, but then also from a fertility standpoint. I mean, especially with nitrogen prices being so high, you don't want to lose more than you need to. And then we also paired the concentration data with some rainfall, and then that kind of, we're trying to pull together the trends between what we're seeing in the water quality and what we're seeing in the environments of these different farms. So this is the results for what we saw for nitrogen concentrations in 2020. With pairing those with the rainfall events, we definitely saw it greater during heavy periods of rain. So this graph that you see, just to orient you all towards this is called the box and whisker plot. And the box covers from 25% at the bottom to 75% at the top. So 50% of your data falls within that box, and the line is the median. So that's where half of it is. And then your whiskers cover 10% and 90% at the top. And I really like these graphs for concentration data because you can't have zero concentration. So this really shows kind of the spread, but then also the average. And what we see is that there are higher nitrogen concentrations in the subsurface tile drainage water than in any surface runoff. But what was really good that we saw was that even though we had higher nitrate losses in the tile drainage, which makes sense, you have water leaching, this is water that would really probably be leaving the fields even, or would be leaching downward, could be leaching downward out of the field even without the drains, but it's kind of expedited, for lack of a better word, because of the tile drains. But what was really good about the data was that 75% of our samples were below 10 parts per million, and that's kind of like the magic number when it comes to drinking water standards. So if you remember a few years ago when the farmers in Iowa all had a big headache because of the Des Moines Waterworks and nitrate losses being too high coming through the city, it was because nitrate losses were above 10 parts per million when it got to the city. So for water to be coming off of our farms at that low drinking water rate, that's really good. And what that means from a management perspective is that you guys are all listening to the fertility guidelines and really getting those nitrate levels pretty close to what the crop needs. Because if you're applying a lot more than you need, you would see much higher nitrate concentrations. It's pretty common in heavy corn production areas where people are applying a lot more nitrogen to see, maybe 30 or maybe 50 parts per million off the farm. So 10 parts per million, really good from a water quality perspective. The other kind of signal that we picked up a little bit, we had a couple farms that were on the valley floor and a couple that were in sandy or beach ridge locations. And some of those samples were a little bit higher at the sandier locations, but that makes sense because you have more water moving through that sandier profile. You guys all know that the beach ridge drains faster, absorbs more water than the heavy clay locations, and so that kind of bears out with the water quality too. So for phosphorus concentrations in 2020, we have the same type of graph here, the box and whisker plots, and these are looking a little bit closer together, but there was, again, we see more concentrations, more nutrients getting to surface runoff when we have higher periods of rainfall. And our phosphorus concentrations, you kind of think of these two graphs. One is a whole order of magnitude lower than the other. And so that means, the highest number on this graph is 14. The highest number on this phosphorus graph is 1.2. So we have much lower phosphorus losses than nitrogen losses. And that's why we don't usually talk about this from an agronomic standpoint, is because, 1 part per million really doesn't bear out that much on the phosphorus rate that you're putting on. But why it's important, and why we saw farmers in Ohio and the Western Lake Erie Basin get into trouble, is that there's some tricky things that happen. You can get algal blooms forming at super low concentrations, like 0.05, so even much lower than this. But that's kind of an unrealistic goal for concentrations off the farm. That's just, you have soil moving, that's just what happens. So we have to kind of think of other ways. And it gets diluted, as it goes through and it gets rainfall. So this doesn't have the direct correlation, a number off the farm to an environmental impact that nitrogen does. So it's really important to keep in mind. But we do see these numbers as as lower than 1 parts per million. And half of them were below 0.1 part per million. This again is a really good result, and the reason I say this is a good result is because even though maybe there's like a 0.05 environmental impact number that's kind of floating out there, 2020 was an exceptionally heavy rainfall year, so we had surface runoff, and surface runoff carries with it the soil. And I think everybody saw, the winter between 2020 and 2021, when we had, not a lot of snow cover, and you can see that soil blowing, that also moves when we have surface runoff. So some of those runoff events we saw in the summer definitely carried some phosphorus with it, but that's an unusual scenario. The other thing that I thought really actually pulled those numbers higher, I'll call out our own farm, the Northwest Research and Outreach Center. We had higher phosphorus losses than our on-farm locations, and I think some of that is because of our new subsurface drainage installation. We had, new tiles dug in 2019, and there was actually a lot of sediment, especially initially in our tile lines. So some of those numbers are actually pulled up because of the construction that happened in fall of 2019. Okay, so just to kind of recap, we saw that heavy rain in 2020, meaning greater nitrogen and phosphorus losses, but drought really meaning we didn't see any water moving, which is also kind of a good news from an environmental standpoint, and from an agronomic standpoint too. There wasn't a lot of fertilizer lost in 2020 or 2021. You didn't lose anything because the water wasn't going anywhere. So we have to kind of look at what the soil moisture is doing beyond the end of when this data set, we analyzed up through maybe October so far, but there could be some interesting things happening in the snowmelt this spring. So that's something that we're going to be keeping an eye on kind of outside of this project, but with some of the other research that we're doing is looking at what's moving in the snowmelt, because that's something we sort of missed in that time period between 2020 and 2021, because there just wasn't a lot of snow cover last year. But yeah, the kind of key takeaways on the fertilizer side, at least on our on-farm sites, I really feel like everybody's doing a good job matching that fertilizer application rate to what's being taken up, and you can see that in the water quality data. And phosphorus, I would just say watch for erosion, because like what we saw, we had all the construction and soil disturbance, that definitely led to higher phosphorus losses in 2020. So with that, thank you all for your support. Again, I'm Lindsay Pease. I'm a soil scientist at the Northwest Research and Outreach Center in Crookston, and you can see me email or follow me on Twitter.
Awesome. Thank you, Lindsay. Everybody give Lindsay a round of applause.
And if you come up with any questions later in the day, I'll be around. So thanks.